Hello, everyone. This is Rick Frage, the sales director at SFTec. Welcome to this exciting webinar, long-awaited webinar, I guess. It's about the bar mesh and its applications. As usual, the presenter is Dr. Girish Narayan. So for those who don't know who Dr. Girish is, he's been working with us for about a year. He has a PhD in civil engineering from the University of Sherbrooke in Quebec, Canada. However, before that, he did earn his Master's of Technology in Earthquake Engineering from the India Institute of Technology. And of course, before that, he had a bachelor's degree in strengthening of reinforced concrete columns with externally bonded FRP, basically. So he has a very diverse experience with us in designing with fiber reinforced polymers. I'll leave the mic to Dr. Girish to start the webinar and dig a little bit deeper in the presentation.
Thank you, Rick. Thank you, Rick, for the brief introduction. So now coming to our main presentation, application of fiber reinforced polymer, bar mesh. The presentation, through this presentation, I will give a brief overview of application of SFTec bar mesh and the alkaline resistant mesh, and a case study on the masonry elements. And finally, I will conclude the presentation. So before going through our main presentation, I would like to talk about our company, SFTec Canada. So our products are mostly designed in Canada and are manufactured in China by Sandok Safety Industry Co. Limited, who are specialized in manufacturing of fiber reinforced polymer products. So we work with national and international engineering firms. We work with them through the design process and help them with the fiber reinforced polymer design standards, whether they are in Canada or in the United States. So we focus on the parking facilities, water treatment plants, and retaining walls. And our main focus is the fiber reinforced polymer bars and alkaline resistance materials. So the fiber reinforced polymer bar is made from composite materials. The composite materials can be fiberglass or carbon fiber or basalt fiber, and it is manufactured by a pultrusion process using a mix of recycled fibers and resins. So the figures show a microscopic view of fiber reinforced polymer bar. You can see the interface resin and fiber. So three different types of fiber reinforced polymer bar, carbon, aramide, and glass, are available. And the stress strain plot shows how these FRP bars are compared with the steel bar. So 2 points should be noted from this plot. First, the glass fiber reinforced polymer bar have lower strength compared to other two fiber reinforced polymer bars. And the second, the strength of all the fiber reinforced polymer bars are higher than steel bar, but however, their behavior is linear elastic up to failure. So in SFTec, we can produce different types of fiber reinforced polymer products depending on the project requirements. Some of the fiber reinforced polymer bars we produce are straight bar, spiral, stirrups for transverse reinforcement, bent bar, and glass fiber reinforced polymer bar shear connectors. The glass fiber reinforced polymer bar is widely used due to its production cost and have better tensile strain compared to other fiber reinforced polymer bars. Some of the advantages of the SFTec glass fiber reinforced polymer bar over the conventional steel bar are it have longer service life because of its corrosion resistance. So therefore improved durability in harsh environments such as construction near coastal areas in North American cold and in non-North American cold climate. The fiber reinforced polymer bar have better resistance against corrosion compared to the steel bar. And as I told earlier, the tensile strength of fiber reinforced polymer bar are 2 to 3 times more than that of the steel bar. However, it have more tensile strength. Fiber reinforced polymer bar are lighter due to low density compared to the steel bar. And due to corrosion resistance, fiber reinforced polymer bar are good for harsh chemical environments as well. And it is neutral to electrical and magnetic disturbance, useful for applications such as in airport, military applications, MRI rooms, and hospitals. Some of the selected field application of the SFTec fiber reinforced polymer bar we have already done in Canada. The glass fiber reinforced polymer reinforced concrete waffle flooring slabs designed with SFT glass, which was built in Halifax, Nova Scotia. And it can also be used for slab on grades. It is a non-structural slab, so it is a one-to-one replacement and save a lot of money compared to the steel bar in terms of labor and transportation. So another project shows the cast on site precast sandwich panel, and they have used our glass fiber reinforced polymer bar in their project as reinforcement, and it was built in China. And in the right is a retaining wall built for City of Montreal. The retaining wall is designed to dump snow with de-icing salts during the winter, and so they built this retaining wall with SFTec glass fiber reinforced polymer bar, which provide resistance against the chemical used in the de-icing salts. So coming to the main presentation, so we should discuss about what are the main common cause of the concrete deterioration. So water is the most common cause of the concrete deterioration because water is porous. Because the concrete is porous, water can seep into the concrete and get to the structure. Water dissolves certain concrete ingredients. The dissolved ingredients flow with the water and collect on the other side. So this process is generally known as leaching. So leaching of the lime compound can lead to the formation of calcium carbonate or calcium sulfate on the surface of the concrete. And there is another phenomena, line bloom, appears as white patches or an overall lightening of the surface of the concrete, which is generally a cosmetic problem. So lime weeping is caused by water leaking through the concrete and dissolving calcium hydroxide from the matrix. Significant leakage can lead to durability problems. So water exposure can rust the steel particles in the concrete and rust the reinforcing bar in the reinforced concrete structure. So rusted steel can be expanded up to 4 times its normal size, causing concrete to break apart. The red streaks on the concrete surfaces is the sign of rust. The concrete corrosion is a result of salt water exposure or sulfur in environment. So the deposit of salted winter roads can accelerate the concrete deterioration. So sulfur can come from a number of sources and can travel in the air and water, making it difficult to combat against it. Sulfur can corrode the ingredients in the concrete mixture as well as the steel reinforcement bars. So the FRP reinforcing bars can be considered in reinforced concrete columns, so reinforced concrete structures due to the following characteristics. The fiber reinforced polymer bars have resistance against moisture, alkali effect, and chemical attack, which mostly depend on the selection of the appropriate resin, manufacturing process, and application of the protective coating. Therefore, the glass fiber reinforced polymer bars have resistance against deterioration due to chloride ions and carbonation. Further, fiber reinforced polymer bars are lightweight, non-conductive, and magnetic free. So the product we are talking about today is the SFTec-Bar Mesh. So SFTec-Bar Mesh is the ideal glass fiber reinforced polymer product that presents a much lighter, sustainable, more durable alternative to regular usually corroded steel mesh products. So there are several types of mesh based on the type of the structure and application. They come into 2 different spacing between the radial and longitudinal bars of either 100 millimeter or 150 millimeter. So the A in this table where I've written DA 100 into 100 by 100. So this A represents the size of the bar, the nominal diameter of the bar in millimeters. So 5 different bar sizes are available from 3 millimeter to 10 millimeter. So the minimum tensile strength of the radial and longitudinal bar varies between 600 to 800 megapascal, and their elastic modulus varies between 45 to 60 gigapascal. So another product is the SFTec alkaline resistance mesh, which is ideal for application that requiring strengthening, like wall strengthening or roof strengthening. So they are available in 4 different types based on the mass space, weight, and strength. The mass space varies from 5 by 5 to 12 by 12, while the weight of the alkaline resistant mesh varies from 110 to 160 gram per square meter. The strength up to failure in radial and longitudinal directions varies from 1000 to 1600 Newton per 5 centimeter. And alkaline resistance, after exposure to alkaline resistance, their strength varies from 800 to 1200 Newton per 5 centimeters, which is generally more than 75% of the unconditioned alkaline resistance mesh strength. So generally by design codes or testing code, it is required to have more than 70%, but it have around more than 75% of its 75% of the remaining strength. The SFTec-Bar Mesh and alkaline resistance mesh should be considered in roof and wall protection from cracking, spalling, and water seepage. Repair of the concrete structures can be used in the flat slab construction or on-grade slabs. Can be used for the pavement overlays. And finally, it can be used in the structure located in the coastal areas, airport, hospitals, and more. So before beginning the case study on fiberglass mesh as sustainable reinforcement for historic masonry, the common problems associated with the brick masonry should be highlighted. Although masonry can deform elastically over long period of time to accommodate small amount of moment, large moments normally causes cracking. Cracks may appear along the mortar joints or through the masonry units. So this cracking can result from a variety of problems, such as differential settlement of foundation, drying, shrinkage, expansion, and contraction due to ambient thermal and moisture variation, improper support over openings, the effect of freeze-thaw cycles, the corrosion of iron and steel wall reinforcement, differential moment between building materials, and bulging or leaning of walls. So above ground brick walls expand in warm weather and contract in cool weather, which develops of stress in the walls that may cause a variety of cracking patterns depending on the configuration of the wall and the number and location of the windows and doors. So such cracks are, which is shown in the figure, are normally reoccurring and will open and close with the season. They will grow wider in the cold weather and narrower in the hot weather. Active cracks must be sealed and inactive cracks may be pointed out. So the application of fiberglass mesh reinforcement to different structural elements such as masonry wall panels, tilt valves, and masonry rings were considered. So GFRP mesh of 66 by 66 millimeter and 33 by 33 millimeter were used in this study. So a shear reinforcement is often needed to increase the lateral capacity of masonry wall panels. So a series of around 17 on-site tests were conducted on wall panels from historic buildings. So the walls panel were reinforced with 66 by 66 glass fiber reinforced polymer mesh, and the average 30-day compressive strength of the mortar was around 21 megapascal. So shear compression test and the diagonal compression test, which is shown in these figures, were conducted on the specimens. So from the test, the unreinforced panels measure a shear strength of 0.032 megapascal compared to a reinforced shear strength of 0.236 megapascal, which is an increase of 640%. So the improvement in the shear strength of the repaired panel were also recorded, and which has an increase of 440%. So the vaulting system often needed to be retrofitted to resist both horizontal and vertical load. So in this investigation, 17 test specimens were constructed with a segmental arch shape using method typically of those employed for many historic bridges were used. The specimen arches had a span of 2000 millimeter with a corresponding height of 700 millimeter above the springle level. So the unreinforced steel arches were built using flat rectangular tiles in 2 or 3 layers, having an overall thickness of 80 or 130 millimeter. So 12 specimens were reinforced with 66 by 66 millimeter glass fiber reinforced polymer mesh. Once the bottom tile layer was in place, a first layer of reinforcement, the GFR, glass fiber reinforced polymer mesh, was directly applied. The glass fiber reinforced polymer mesh was cut to a length of 3000 millimeter and width of 300 millimeter, covering the top side of the arch length and width, which is shown in the figure A. The specimen were tested by applying a vertical compression load at vault crown, which is also shown in the figure B. So the use of glass fiber reinforced polymer mesh inserted both into the mortar bed joints and on the outer surface of the arch permitted the attainment of capacity increases, which range from 300 to 570%. So in conclusion, so due to the many advantages of the fiber reinforced polymer bar mesh and alkaline resistant mesh, it can be used in many civil infrastructure projects like in the roof and wall protections, pavement overlays, concrete repairs, and in coastal areas. As seen in the case study of fiberglass mesh, the effective use of fiber reinforced polymer bar mesh could significantly improve the shear strength and load capacity of the unreinforced wall panels. And due to the alkaline resistance, the fiberglass mesh and alkaline resistance mesh can be used as the roof and wall protection, which can prevent salt water and sulfur damage and improves the service life of the structures. So these are the different other products which are manufactured by SFTec Inc. And following are the design codes for the design of glass fiber reinforced polymer structures. Thank you very much.
Very much, Dr. Girish, for this informative presentation.
Yeah, you can use it. You can use the glass fiber reinforced polymer mass in this kind of slabs, Hambro slabs. So you have to put it in the you can put it in by layers, but before putting the mortar, you have to put this mass. I think 2 layers of the masses should be required at the top and bottom. We can use the GFRP reinforcement like glass fiber reinforced polymer bars in both column and beams. And here are the following codes. We can use these codes to design those elements, beams and columns. So ACI 440 is the latest code, which is published last year only in 2022. And if you read this code, ACI 440, it is similar to the ACI 318 code. And the CSA S806 is the code used in the Canada. And this code is similar to the CSA A23.3. So you can use this code to design those elements, both beams and columns, as well as slab if you want. Yes, the alkaline resistance band can be used for the shrinkage cracks, for stopping any shrinkage cracks. Is the similar as what the carbon ARMesh is used, is the same.
Okay. So for technical questions, you can contact Dr. Girish directly, and for sales related questions, my email is to the right. Please